So here we have the integral from 1 to -1, I know it's a little backwards, of the natural log of 1 minus x all over x with respect to x. And as I mentioned, we're going to have to know the power series for the natural log of 1 minus x, which I'll talk about. And we need to know the Basel problem right here. And then this is the values for all the odd values in the Basel problem. But again, more on that later. Which, by the way, you best believe I talk about this in Book of Marvelous Integrals. There's something called the power series, which is gonna look like this. You have n to the power of 0, this is x to the power of n, and this is gonna equal to 1 over 1 minus x. And this is provided that the absolute value of x is less than 1. Let's go ahead and integrate both sides. Well, on this side right here, if you did some simple u substitution, you will get that this is negative natural log of 1 minus x. Over here, we're really just doing the power rule, so this will be x to the power of n plus 1 all over n plus 1. Let's go ahead and introduce the negative on here, and then we're going to put the negative on the outside here, and this will give us the integral from, or negative, integral 1 to -1 of summation from n is equal to 0 of x to the power of n plus 1 all over n plus 1 times, and then this is in the denominator, so we'll do 1 over x with respect to x. We're going to flip this and make this -1 to 1. We have this series here, and let's go ahead and combine the x's. We'll get that this is x to the n over n plus 1 with respect to x. What we really have is a summation from 0 to infinity of the integral from -1 to 1 of x to the n over n plus 1 dx. So what we have now is we have summation from 0 to infinity of, and then we're going to have x to the n plus 1 over. So this will become n plus 1 squared, and then from -1 to 1. I don't know if you're noticing, like, the Basel problem is coming. This will give us summation from 0 to infinity of 1 over n plus 1 squared minus summation from 0 to infinity of -1 to the n plus 1 all over n plus 1 squared. Give me 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared, yada, 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 minus -1 over, and then you plug in 0 here, so you have 1 squared, plus 1 over 2 squared, minus 1 over 3 squared, plus 1 over 4 squared, minus on and on and on. 1 squared plus 1, 2 squared, plus 1 over 3 squared, plus 1 over 4 squared, on and on and on, plus 1 over 1 squared, minus 1 over 2 squared, and then plus 1 over 3 squared, minus 1 over 4 squared. So what's going to happen is all the odd values are going to become positive, and all the even values are just going to become negative. All the even values are going away, but what we have is twice the amount of odd values, because we have 2 times the amount of the odd values. As I mentioned, this are the odd values of the Basel problem. We get 2 times pi squared over 8, which of course we can simplify to pi squared over 4, and we are done.